we will talk about permutation. But before that, let's have first an activity. So let's start. Okay, so let's assume that we have here 3 cards. 1, 2, and 3. So we will arrange these 3 cards. So as you can see, we have here table. So first, get any 2 cards. So for example, we have 1 and 2. So let's arrange these 2 cards one piece at a time. So we have 1 and 2. So we have 2 possible arrangements. So the number of objects here or our n is 2, and the number of objects taken at a time or our r is 1. So the number of possible arrangements is 2. So next, arrange 2 cards, both pieces at a time. So we have 1, 2, and 2, 1. So how many arrangements there is? So we have 1 and 2. So there are 2 possible arrangements. So next, get any 3 cards. So we have 1, 2, and 3, for example. So arrange these 3 cards one piece at a time. So there are 1, 2, and 3. So there are 3 possible arrangements. So the number of objects there is 3, and the number of objects taken at a time or our r is 1. Then the number of possible arrangements is 3. Next, arrange 3 cards 2 pieces at a time. So let's see. We have 1, 2, 1 and 3, 2 and 1, 2 and 3, 3 and 1, and 3 and 2. So let's count how many possible arrangements. 1, 2, 3, 4, 5, 6. So there are 6 possible arrangements if we arrange 3 cards 2 pieces at a time. So next, arrange 3 cards at 3 cards at a time. So we will use these 3 pieces. So we have now 1, 2, and 3. 1, 3, 2. 2, 3, 1. 2, 3, 2, 1, 3. And 3, 2, 1, 3, 1, and 2. So how many possible arrangements there is? So we have 1, 2, 3, 4, 5, 6. So there are 6 possible arrangements if we arrange 3 cards at a time. Okay, so we have 6. Okay, so let's have another example. Suppose you secured your bike using a combination lock. Later, you realize that you forgot the 4-digit code. You only remember that the code contains the digits 1, 3, 4, and 7. So let us list all the possible codes out of the given digits. So how many possible codes are there? So there are 24 possible codes. So what do you call these arrangements? Yes, we call it permutation. But what is permutation? So permutation refers to the possible arrangements of a set of objects. Permutation of n objects taken r at a time is denoted by permutation of n objects taken r at a time. Again, this can be read as permutation of n objects taken r at a time, where n is the total number of objects and r is the number of objects taken at a time. Note that the value of our n must be always greater than or equal to r. So let's now proceed to the formula. So if permutation of n objects taken r at a time is given, then we will use this formula. Permutation of n objects taken r at a time is equal to n factorial over n minus r factorial. Now, if permutation of n objects taken all at a time is given, then we will use this formula. Permutation of n objects taken r at a time is equal to n factorial. Okay, so let's have another example. So if there are 3 persons named Alex, Bob, and Mark, in how many ways could these 3 people line up? So we will use the formula permutation of n objects taken r at a time is equal to n factorial. It is because wala man din stay sa aton nga problem if how many number of objects taken at a time. So ang aton nga n is 3. And our r also is 3. So, proceed to our formula. So, permutation of n objects, permutation of 3 objects taken 3 at a time is equal to 3 factorial. So, let's do that. Permutation of 3 objects taken 3 at a time is equal to 3 times 2 times 1. So, let's now multiply. Permutation of 3 times 2 times 1 is equal to 6. So, there are 6 possible ways to the 3 persons named Alex, Bob, and Mark could line up. So, let's have another example. Suppose we have 4 different potted plants and we wish to arrange 3 of them in a row. In how many ways can these be done? Note that there are r factors. So we will use the formula permutation of n objects taken r at a time is equal to n factorial over n minus r factorial. So the value of our n is 4. And the value of our r is 3. So substitute to the formula. Permutation of 4 objects taken 3 at a time is equal to the value of our n is 4 factorial. 4 minus 3 factorial. So 4 factorial, it means 4 times 3 times 2 times 1. So 4 minus 3 is 1. So we have 1 factorial. Okay, so permutation of 4 objects taken 3 at a time is equal to 4 times 3 is 12 times 2 is 24. So we have 24 possible arrangement. So let's have another example. So in how many ways can you place 9 different books on a shelf if there is a space enough for only 5 books? So our n is 9 and our r is 5. So our formula is permutation of objects. So substitute to our formula. Permutation of 9 objects taking 5 at a time is equal to 9 factorial over 9 minus 5 factorial. So our equal to 9 factorial is equal to 9 times 8 times 7 times 6 is 9 minus 5 is 4 factorial. So, pwede din siya natin i-4 factorial. Kaya pwede din siya ma-eliminate. So, we have permutation of 9 objects taken 5 at a time is equal to, so, pwede din siya ma-eliminate ang 4 factorial. Eliminate. So, 9 times 8 times 7 times 6 times 5. We have 15,120 ways in placing the 9 different books on a shelf if there is space for only 5 books. Okay, so let's go now to the distinguishable and circular permutation. So notice that in the previous examples, the objects to be arranged are all distinct. So what if some of the objects are not distinct? Some are identical. So let's consider this example. Find the number of permutation of the letters of the word statistics. are 10 letters of the word. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our N is 10. However, we have to take consideration that there are 3 S, 3 T, and 2 I. That is what we call distinguishable permutation. So when we say distinguishable permutations, it refers to the permutations of a set of objects where some of them are alike. Nga ang iban sa ila parehos. Okay, so our formula for distinguishable permutation is permutation of n objects taken R at a time is equal to n factorial over p factorial, q factorial, and r factorial. Okay, so our n is 10. So our p now is 3 for our s. And our q is 3 and r is 2 for our I. So let's now substitute to our formula. So permutation is equal to n factorial. Our n is 10. So 10 factorial. P factorial. P is 3. So 3 factorial. And our q is 3. Our r is 2. Okay, so permutation is equal to, so let's now substitute the value to our formula. So n, our n is 10. So 10 factorial. Our p is 3, q is 3, and our r is 2. So let's see. So 10 factorial is equal to 10 times 9, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 3 factorial is 3 times 2 times 1. 3 factorial, 3 times 2 times 1. And 2 is 2 times 1. So, let's multiply. We have 10 times 9 and so on is 3,628,800. Okay, so multiply these numbers. In the denominator, we have 72. Now, 362 ay 3,628,800 divided by 72 is equal to 50,400. So, there are 50,400 permutations. So, let's have another example. So, how many possible permutations are there in the letters of the word Philippines? Philippines. So, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, our N is 11. So, our P is, we have P are alike, 1, 2, 3. We have P is 3. And our Q is 3 also. For our I, 1, 2, 3. We have 3 I's. So, substitute to our formula. Factorial over P, Q factorial. So, we have now permutation is equal to n factorial. We have 11 factorial. Our P is 3 and our Q is 3. Okay, so we have 11 times 10 times 9, 8, 7, 6, 3, and 1 over 3 times 2 times 1 and 3 times 2 times 1. So our permutation is equal to, so multiply all these numbers. We have 39,916,800 over 3 times 2 is 6 times 3 is 9. 18 and times 2 is 36. So we have 36. So 39,916 and 800 divided by 36. We can get 1,108,800. So there are 1,108,800 permutation. So let us now consider arrangements of objects in a circle, which we call circular permutations. So when we say circular permutation, it refers to the different possible arrangements of objects in a circle. So the number of permutations, P of n objects around a circle, is given by P is equal to n minus 1 factorial. So for our example, in how many ways can 4 people be seated around a circular table? So our n in this problem is 4. So substitute to our formula. So P now is equal to 4 minus 1 factorial. So P is equal to 4 minus 1 is 3 factorial. P, 3 times 2 times 1. So 3 times 2 times 1 is equal to 6. So our P now is 6. So we have 6 possible ways that 4 people can be seated around a circle table. So let's have another example. To find the number of different ways that a family of 6 can be seated around a circular table with 6 chairs. So our formula is P is equal to n minus 1 factorial. So our n is 6. So substitute to our formula. So P now is equal to 6 minus 1 factorial. P is equal to 6 minus 1 is 5 factorial. So P is equal to 5 factorial. We have 5 times 4 times 3 times 2 times 1. So multiply all these numbers. We have P is equal to 120. So there are 120 possible ways. So that's all for today's video, guys, and I hope you have learned from our discussion. Thank you for watching.